Hello everyone. Today let's solve the problem number 79, word search. Right. So what the question states here, we are given an m into n character grid. Right. So we are given an m into n character grid board and a string word you can clearly see here. Right. So you can clearly see here and a string word. We have to return true if the word exists in the grid. So we have to return true if the word, this word, whatever they have given here, A, B, C, C, E, D, which consists of the letters A, B, C, C, E, D, if this word consists in the this grid, basically board, right? So if this word exists in the grid by forming it using sequentially adjacent cells, so we can use it. I mean, we can form it using sequentially adjacent cells. That's what they have given. Means sequentially adjacent cells means either we can move one step horizontally or vertically, right? So either we can move one step horizontally or vertically, right? A cell cannot be used more than once in a single search path. So they have clearly mentioned a cell cannot be used more than once in a single search path. This is very important. Just keep this in mind. So we have to check whether the word is present in the board or not. That's what the main question states. So if it is present, then we have to return true. If it is not present, then we have to return false in that case. So the conditions here is we have to make sure that a cell cannot be used more than once in a single search path, and also we have to return true if the word exists in the grid by forming it using sequentially adjacent cells, either horizontally or vertically, right? Just keep this in mind. These are the conditions they have given, or these are the requirements they have given correctly, right? So let's come to the first example here. You can clearly see, so it starts from the first cell here, 0, 0, right? So this one, either we can move one step horizontally or vertically. So we will move this side, right? So then we will move again right here. B is present and C is present. We will check first A, B, C is present. Again, one more time we have to check for C because C is present twice here in the word, right? So again, so we can just search down here, right? So C is present. Now C is marked. After C, then we have to search for E. E is present down. This is fine. Next we will search left. D is present. So the letters present in the word, complete word. So here A, B, C, C, E, D is present in the word, right? Accordingly with the requirement that we have considered. Two requirements we have considered right here. We have moved only one step vertically or horizontally in this case. So in this case, the word is found, so we have to return true. So all the characters in the word are present in the board, right? So we have to return true in this case. This is fine. Let's come to the let's come to the example 2 here. So just give me a second here. So here we can clearly see we have SEE, right? S, we will start from here. So we will start from here. This is 1, 3, right? So we'll start from 1, 3 here. Then we will move down. Then we will move left. In this case, all the characters that is present in the word, all the characters in the word is present in the board. So again, we will return true in this case. This is fine. Easy, right? So let's come to the third example here. So here in this case, we have been given A, B, C, B, right? So we will check first 0, 0. A is present. So we'll move right here in this case. B is present. This is fine. C is present. This is fine. But again, B has to be present somewhere, right? So B is not present right, not present down as well. Either we can move vertically or horizontally. So vertically C is present, horizontally E is present. So we'll check somewhere A, whether it starts from A again or not. So here this is fine. Here you cannot start because SFCS we have. So we can start from here A. So A, B is not present at all here. B is not present at all. So vertically or horizontally, B is not present at all. So overall A, B, C, B is not the characters that is present in the word is not present in the board. In this case, we have to return false, right? So I hope this is completely clear. Easy to understand, right? So just give me a second here. Yeah, I hope the question is completely clear. What we need to do is completely clear as well, right? So first, let's discuss the approach followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the up. So the first thing that we need to keep in mind is we'll be going with the backtrack and DFS approach. or backtracking plus DFS approach. Just keep this in mind. We'll be making use of the backtracking as well as the DFS. Right. So I hope this is clear. I have considered the first example, the same example that they have given in the question, the first example, right? So that it will be easier to understand. We have already discussed this one, right? So we have already discussed this one. So the output that we need to get here is true, because all the characters that is present in word are present in the word, right? So let's move on with the step-by-step execution here. Same first example we have considered, right? So the first step here is we will start scanning the board initially. We will start scanning the board. First match is found at 0, 0. Means here in this case, so we have, so let me consider this one ABCCED, right? So here let me write it here itself. So word equals ABCCED. So this is fine. So we will first scan the board. First match is presented this one. First match means A. A is presented 0, 0. Here this one. So we will mark this one. We will mark this one. First match is presented 0, 0. We will mark this one. Why we are marking this one? So that we will not check this one again, right? So that we will not check this one, check this cell again, right? So next step here is, let's come to the second step here. We will move right to 0, 1. We'll move right to 0, 1 here in this case. So here we have the letter B, right? So we have found the letter B here in this case. So we'll just come here itself. We have found the letter B. Either we can move one step horizontally or one step vertically. So horizontally we have moved one step and we have found B here. This is fine at 0, 1. So the next step, let's move on with the next step. So we will check for C. So we have to check for C in this case. So we will move horizontally again and we have found C and we will mark this cell basically. After finding the particular character, we will mark that cell so that we don't check that cell again, right? So we don't have to check that cell again, right? So next step here is we'll go searching for C basically. So here we'll check horizontally, we'll check vertically. We have found C. We will mark this cell as visited, right? So we'll mark this cell as visited, right? So this is fine. So the next step here is we have to search for E, right? So we will we'll search this one vertically, means down basically vertically, and we have found E and we will mark this cell. Same goes with the last letter as well, D, right? Same goes with the last letter as well, D here. In this case, we will move left one step, means horizontally. We have found D and we will mark this cell, right? So now we have found all the letters that were present in the world, in the board, right? So this is the board. We have found all the letters that were present in the world. So if we have found all the letters that is present in the board accordingly with the requirements, so by moving horizontally or vertically one step, then we have to return true in that case, right? So we have found all the letters in the word in the board, right? So in that case, so here now we have found A, B, C, C, E, D. In that case, we will return true. So why we have returned true? Because we have found all the letters that were present in the word in the board. So in this case, we will be returning true. So we made use of the DFS, right? For moving either left, down, up or bottom, we will be making use of the this one DFS. We can either move one step right, left, up or down, right? So we can just move one step vertically or horizontally. So we have made use of DFS basically, right? So and we have successfully found all the letters, or we have successfully found the word in the board. So that is the reason we have returned true. So the output that we got is true, and the output that they have given for the first example is also true. So here, so this one approach works absolutely correct in this case. The output that we got is equivalent to the output that they have given for the first question, right? So the approach works absolutely correct in this case. So as we are familiar with the approach, now let's quickly discuss the edge cases one by one, right? So the first edge case is for word exists in the middle. Word exists in the middle. You can just draw the board and you can just check here, right? I insist you to draw the board and check so that you'll understand this one clearly, right? So word we have been given only BD, right? So you can just draw. I'll just draw this for this particular edge case. You can draw for the other, right? You can draw for the other edge cases and check. So here in this case, we will move, this one will start from B and we will move one step D here, right? So we'll start from 0, 1. This is 0, 0, 0, 1, 1, 0, 1, 1, right? So we'll start from 0, 1 and we'll move one step down. So we have found BD here. So basically this is not BD actually. We'll be considering AD. So here this is A and this is D. So we can move either horizontally or vertically, right? So we cannot move diagonally. In this case AD, so for AD we cannot move diagonally, right? So in this case we will return false. Sorry, so I considered BD. So if we consider BD, it would be true, right? So I considered AD here. In this case we cannot move diagonally, right? So we can either move horizontally, next means left or right, or up, this one up or down, right? Up or bottom, right? So one step. So let's come to the second part here, or the second example, second edge case here. Word is longer than all the cells. Here in this case word is AB, but we have only A in the board, then we have to return false, right? So word is longer than all the cells here. In this case we have to return false, means not enough letters in the board to form the word. We know this one, so we will return false in this case. Let's move on with the third edge case here. Word is a single letter. So word is a single letter here. In this case word we have A, and board, in the board also we have A. In this case we have to return true in this case, right? So we have single letter that matches the word basically, so we'll be returning true in this case. Let's move on with the fourth edge case here. Repeating letters but cannot reuse cells. Repeating letters but we cannot return the cell. So here we have ABA, right? AB. So repeating letters but cannot reuse cells. Here in this case it is A. Sorry, not, this is not B, basically this is A. So this is fine. So here in this case ABCA we don't have the A present 3 times in the board at all. So in this case also we will return false, right? So these are the 3 edge cases that we need to keep in mind. So the first edge case is for the word exists in the middle. The second edge case is for word is longer than all cells. And the third edge case is for word is a single letter. And the final edge case is for the repeating letters but cannot reuse cells, right? So this is fine. So these are the edge cases that we need to consider. So this is not the repeating letters but cannot reuse cells. This is just repeating letters, that's it. Not but cannot reuse cells. I'll just erase this one. This is just repeat. This is just for the condition repeating letters. So this is fine. So this is it for the these are the 4 edge cases actually we discussed, right? Now we are completely familiar with the approach as well as the edge cases. So now let's start writing the code. So initially what we'll do, let's get the row as well as the column count, right? So I'll just give here, and for the row count I'll just go with, sorry, board we have as the parameter, right? Yeah, this is length of the board. And to get the column count I'll just give here, I'll just make use of calls keyword here. So board of 0 dot length. This is fine. So the next step here is we have to iterate over all the cells. Why we have to iterate over all the cells? Because we have to find the starting match, right? In our case, in the first example, the starting match was 0, 0, if you remember. So we have to iterate over all the cells to find the starting match. So let me make use of the for loop here. In I equals 0, I less than rows, right? Length of the rows, sorry, it is just rows, not the length of the rows here. So we have to do the same thing for the columns as well. So I'll just go with for int j equals 0, j less than all j plus plus. This is fine. So the next step is we have to start the DFS if the first letter matches. If the first letter matches, then we have to start the DFS, because we have to check whether other letters in the word is present in the board or not, right? That is the reason we have to start DFS. DFS means either we can move one step up, left, down, or right, horizontally or vertically. So for that, I'll just write simple if condition here. If of we'll be making use of the backtrack basically. So we'll be, again I'm telling, we'll be making use of the backtrack here. So first, what shall we do? Let's write the backtrack function first. I'll be making use of the backtrack helper function, right? So let's write the backtrack helper function first, then let's make use of the same thing in the main function, right? So let me come here in this case. So I'll just come here, just give me a second here. So I'll just give here private boolean. So I'll just go with the name, function name backtrack here. So I'll give char this one board, as we are dealing with the grid, right? So I'll just go with a word which is of the type string. I'll just consider word as parameter. This will be row, column, and index. This is fine. So within this one, first the base case is if the entire word is found, then we have to return true, right? So here if index equals length of the word, word dot length. So this has to be function Java. So this is fine. So in this case, we have to return true, right? This is fine. So the next step is if out of bounds or mismatch, then we have to return false for the row and column, right? So I'll just write simple if condition here. If row less than 0 or row greater than or equal to length of the board, means board dot length here, or column less than 0 or column greater than or equal to 0 dot length, right? So this is fine. Also this one also we have to keep in mind, board of row column, this one, if it is not equal to this one word dot, so I'll just make use of caret index, then what we will do, we have to return false in that case. So I'll just give here return false. This is fine. So the next step here is what we need to do here, we have to store the current character and we have to mark that one as visited. Once we visit the particular cell, we have to mark that one as visited, right? So that we don't have to visit the particular cell again, right? So this will be char temp equals board of, so row, and for the column we have considered call, sorry. So this is fine. So we have to mark that one as visited, right? So I'll just do it here, board of, sorry, not board, I'll just type this one again, board of row column, this one, for marking visited I'll just make use of the hash here. This is fine. So as we are going with the DFS, we have to explore all the 4 directions. We know this one, right? Either down, up, left, or right. So we have to explore all the 4 directions. So I'll just go with boolean here, found. Then let me make use of the function backtrack here. Let me paste it over here in this case. So we have board word. So let me copy this one, board word parameters. So let me paste the same thing over here, row, column, and index, right? So here row, column, this one, this parameter which is of the type and we have index. So let me copy the same thing as well here. So this is fine. So for down, we'll be going with row plus 1 and index plus 1, right? So I'll just go with row plus 1 and index plus 1. This is for the down. We have to explore 3 more directions, up, right, and left. So let me copy the same thing here. So I'll just do one thing. let me copy only this part, right? So we only need this part. So this one I have to go with R. Instead I have given semicolon. Let me change this one. So this is fine. So let me paste it over here. Again let me paste it over here. Again let me paste it over here. So let me give here R. So again let me give here R. This one, let me close this one with the semicolon. So first one was for down. Next, instead of row plus 1, let's go with row minus 1 for the up. So this one will be index plus 1 itself. So for right, we will be going with the column plus 1 instead of row plus 1, right? So I'll just go with here column plus 1. This will be index plus 1 itself. Index plus 1 remains the same. So this will be same, index plus 1 will be same. This will be column minus 1 for the left basically. Let me remove this one. This will just be row. So now we have successfully explored all the 4 directions, right, by making use of this code. So this is fine. The next step is we have to restore the character, nothing but we have to go for the backtracking. So here in this case I can write in this way, right? Board of row column. This one, let me assign this one to the temp. So one thing, so let me give here return temp. This is fine. I return not the temp, sorry, return, we have to return the found right here. So this one I'm speaking of, why I have given this is fine. So return found. So return found means we have to return if word was found while exploring all the 4 directions, right? So that's what. I hope this is completely clear. This is it for the helper function backtrack, right? So now we'll be making use of the same backtrack function within the main function, the helper function within the main function basically. So I'll just go with here if backtrack of, let me copy the parameters. What were the parameters basically? Board, word, I, j and 0, right? Let me paste, let me type this one. Board, word, I, j and 0. So we are starting the DFS if the first letter basically matches. Nothing but in the first example, it is from 0, 0. A matched 0, 0. This one I'm speaking of, example 1. This one, right? So this is fine. So the next step is we have to return true if the word is found. So then let me open the bracket here. So I'll just give here the boolean value true. We just have to return true. Else if no path is found, then we have to return false in that case. So let me come here and give return false. This is fine. So let me format the code once and let me hit the run button. So I hope this works, man. Let's see. So we have some error here. Let's see. Line number 33 we have some error. Let me come to line number 33 here. So yeah, this one I have misspelled bold, right? So this is fine. Let me hit the run button again. Expected. What is expected here? Saying square bracket except this is fine. Line number 33. Let's solve this one. Board of row. Oh yeah, column I have. This is fine. One line number illegal start of expression. Same thing. 33. Return found. So this one. Oh yeah, this one. Let me remove this one. So this one has to be here after the column, right? The square bracket. So this is fine. So let me hit the run button again. Again I have misspelled board in the line number 4. Let me come to line number 4 quickly. So many typos. So I'll just give here board. This is fine. Yeah, this is it. I think now this has to work. Let's see. Compile error we have. Method caret. Something is wrong. Let's check what is wrong. In the line number 21. Let's come to line number 21 here. So yeah, what mistake I have done, they have clearly mentioned here, right? So instead of caret, I have given chatted. So I have again misspelled here. So I'll just make this one char instead of this one. T instead of T, I have made this one R. So let me run this one again. I hope this works now at least. Let's see. So yeah, now you can clearly see all the test cases are getting, all the sample test cases are getting passed. So let me hit the submit button quickly. So now you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case. So now let's quickly discuss the complexities for the code that we have written. Right. So the approach that we went with here is, we know this one, backtracking plus DFS or depth first search. So overall time complexity would be here in this case. It would be big O of m into n into 4 into 4 to the power of L. Sorry, not 4, this one. 4 to the power of L, right? So this is fine. This is the time complexity. And what would be the space complexity here? The overall space complexity would be big O of L here. This is fine. The overall space complexity would be big O of L. So why it is here, this one, big O of m into n into 4 to the power of L? Because m into n, because we are iterating over all the cells as the starting point, right? So we are iterating over all the cells as a starting point. We can just start from n. So just see. So in this case, in the first example, it starts from A. So suppose if the word starts from F, so suppose if we had F, C, E as word, so we have to start from F, right? So in this case, we are iterating over all the cells as starting point. So it is big of m into n in this case. So each letter can explore 4 possible direction. One is up, down, right, or left. 4 possible direction: horizontal and vertical, right? Horizontal and vertical. So in this case, overall time complexity would be big of m into n into 4 to the power of L, right? So that's what I have done here. So why the space complexity here is big of L? Because recursive depth, we are making use of the recursion. So we are going with the helper function and we are making use of this one, recursion here as well. Somewhere backtrack this one while to explore all the possible direction. Also, we are making use of the helper function here within the main function as well. We are going with the recursion. Recursive depth is at most L in this case, nothing but word length due to the backtracking. So overall space complexity I have given here as big of L. Sorry, yeah, the time complexity and the space complexity, the code that we have written as big of m into n into 4 to the power of L, and the space complexity is big of L, right? So I hope the complexities are clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.